relationship? Which formula we will use here? Which formula to be used?
Yeah, 1 plus h by r to the whole power minus 2.
Yes, we had this expression g dash over g is equal to 1 plus h by r whole to the power minus 2, and we have to use this formula to find out this g dash by g. We have been given the value of h, we have been given the value of r. So can you tell the answer? Which one will be the correct one? Oh, come on, simplify. So g dash by g equals 1 plus 3200 over 6400. They are in kilometers, and since you are taking the ratio, no need of putting the units. So minus 2, you get g dash over g. Yes, tell the answer quickly. 1 plus 1 by 2, isn't it? Power minus 2. Then take the square to the other side, make it square root, and obtain the answer. So you'll get your answer here as 3 by 2. 3 by 2 power minus 2 g dash by g. Okay. So g dash. Now we want to find out g dash. So can we find out now? If you reciprocate it, so if you reciprocate, you get here g by g dash equals 2 by 3 whole squared, and g by g dash would be equal to 4 by 9. So g dash will be equal to g multiply 9 by 4. Okay. So now putting the values, tell the answer. I want the answer from you people within, I'm giving you 1 more minute. I'm expecting the answer within yes. Who else has got the answer? You can take out this ratio w by w dash, m and m will get cancelled. We want to find out w dash. Okay. So we have already got g by g dash. G by g dash is 4 by 9. So w by w dash, w is known to us as 18 over w dash will be equal to g by g dash, that's 4 by 9. So w dash will be equal to 18 times of, yes, what should be the answer?
Sir, is it 8?
Yeah, the correct answer is 8 Newton. Okay, so I think now you can do this. Let's try another one. The next question. Everyone has got the answer?
Yes, sir.
Okay. So, okay, now see the question number 2. Given below are two statements. Statement 1, acceleration due to Earth's gravity decreases as you go up or down from Earth's surface. So is this statement correct? Here we can use the binomial concept. Using the binomial concept, we had g dash is equal to g times of 1 minus 2h by r. And for variation with depth, we had G dash equal to G times of 1 minus D by R. So here something is subtracted from 1. So of course the new acceleration due to gravity will be less in both the cases. So what about statement 1? Will this be correct or not?
Yes, sir.
Yes. Niharika, are you getting?
Yes, sir.
Okay. So please pick up the answers quickly. I want to take you speed up. Okay, what about the second one? Acceleration due to Earth's gravity is same at a height h and depth d from Earth's surface. So it says that g dash will be same at a certain height h and at a certain depth d if h is equal to d. So if you put h is equal to d, are you getting to both the expressions equal?
No, sir.
No, both the expressions are not getting equal. So that means my statement 2 is false and statement 1 is correct. Okay. So statement 1 is incorrect. That is false. Both statement 1 and statement 2 are incorrect. This is also false. Statement 1 is correct, but statement 2 is incorrect. This is the correct one. So your correct answer is for 3. Option 3. See here. This question we had done, but I hope you will be able to utilize your concepts and do it. If the distance of Earth from the Sun is 1.5 times 10 to the power 6 kilometer, then the distance of an imaginary planet from the Sun, if its period of revolution is 2.83 years each. So here we have to find out a relationship between distance, and time period. So is there any relationship between distance and time period?
T square is directly proportional to R cube.
Yeah. So we will utilize this concept T square proportional to R cube. So first we will utilize this for the Earth, then we will utilize this for the planet, divide both of them and obtain the ratio. Therefore, we can find out the distance. We can find out the distance. So what all things are given here? The distance of Earth is given, let's represent it by RE. So RE is given as 1.5 multiplied 10 to the power 6 kilometer. Then for the planet distance, and we also know the time period for Earth. What is the time period for Earth?
1.
No, for the time period of what is the time period of revolution for Earth? 1 year. Yes, it's 1 year. Okay, it's 1 year, and we can use the concept. This we have got for the planet. Time is given. So this is for Earth, and time for planet is given as 2.83. So you can put the concepts here. Put here T for Earth, T square for Earth, proportional to R cube of Earth, and divided by T square for planet, proportional to R cube of the planet. Okay. So putting the value T square for Earth is 1, and whatever, even if we write it equal, so we can write it as equal, and here some constant K, here also equal and some constant K. Constant and constant will cancel. So you will have a T square, that's 1 squared equal to R cube. Okay. R is 1.5 multiplied 10 to the power 6 whole cube divided over T square, which is 2.83 squared, will be equal to R cube. So here I want to find out R cube then. So I have R cube equals to 1.5 multiply 10 to the power 6 whole cube multiplied by 2.83 whole squared. Okay. Now, since I want to find out r, so I will be taking cube root. So r will be equal to, if you find out cube root for this, so it should be equal to 1.5 multiply 10 to the power 6. This is what we get. Then multiply 2.83 power 2 by 3. So 2 by 3 means you first square it and then try to find out the cube root. So what's the square of 2.83? Can you try to find out the square of 2.83?
Sir, roughly 2.
Roughly 2. Square, not square root. I want to find out square of 2.83.
Roughly 9 then.
No, it's 8. You will be getting this 2.8. If you find 2.8 is 83 is the square root of 8. So you multiply this 2.8 multiply 2.83. If you multiply, you will get 8 point something. So this is your 8. And this is your, if you have to find cube root of it. So cube root of 8 is 2. So you take here 2 and hence you get 1.5 multiply 2 multiply 10 to the power 6. 1.5 multiply 2 is 3. So which option is correct?
Option 3.
Yes, we are correct with option 3. Now we can move to the next one. Given below are two statements. One is labeled as assertion and the other is labeled as region. So everything is given. Read the statements. Assertion says a pendulum clock when taken to Mount Everest becomes fast. So when you are taking to Mount Everest, the height increases. And we have studied the variation of acceleration due to gravity with height. And they are also talking about the time period of pendulum. So the time period of pendulum is given by t equals 2 pi under root L by g. So here we observe that the time period is inversely proportional to g. If g will be greater, time period will be smaller. That means it will be moving faster. If g will be smaller, so time period will be greater. Okay. So what should happen? What can you say about assertion? What over there we will have on the Mount Everest, we will have time period t will be equal to 2 pi under root L by g dash, whereas g dash will be less than g. We will have a fall in the value of g at a certain height.
Sir, assertion is false.
Yeah, we got here assertion is false. It will not move faster. Here the value of g decreases, so time period increases. Time period increases means it becomes slow. So assertion is false. And now if we read the region, the value of g acceleration due to gravity is less at Mount Everest. Okay, so is region correct? It says the value of g acceleration due to gravity is less at Mount Everest than its value on the surface of Earth. So is this correct?
Yes, sir.
Yes. So this statement is correct. And so which option we will go with? Assertion A is not correct, but R is correct. That is again option 3. Got it?
Yes, sir.
Okay. So now we can move to the next question. Javian, are you getting? Yes, Javian. Okay. See this question. Assume that the Earth is a solid sphere of uniform density and a tunnel is dug along its diameter throughout the earth. It is found that when a particle is released in this tunnel, it executes a simple harmonic motion. The mass of particle is 100 grams. The time period of motion of the particle will be approximately. So you have to find out here the time period of motion, time period of SHM. So this question is related to SHM. Are all of you are ready with SHM? So are you ready with that? We can start. Can we start with it?
Yes, sir.
Okay. So see, uh, with the SHM, when you are doing the questions of SHM, what is your ideology? How do we go about finding the solution to the questions when you have to find out the time period? And so for these questions, you need to find out the driving force here, the force which is causing the SHM. We need to find out that force. And if that force, if we get that force to be proportional to, if that force is proportional to negative of displacement, okay. So you will be having force proportional to negative of displacement, or you have something like F equals to negative of some constant multiply Y. So in this case, we will be having uh, in this case the acceleration for force we can put mass times acceleration. This will be an SHM, and we can put ma equals to minus ky, and hence acceleration will be equal to minus of k by m times of y. As we know the so this value should be equated to omega squared. We equate this value to omega squared and we put omega squared as k by m. Okay. Since omega is 2 pi by t, and then we can find out all the other values. So from here, omega will be equal to under root of k by m, and omega is 2 pi by t. So I can write it, I can find out time period from this expression. Okay. So this will be the ideology. We will use this concept here also. Okay. We will find out that whether it follows this SHM or not. So for this, we have done the variation of acceleration due to gravity with depth. Okay. So if you have a tunnel and through the tunnel a ball is dropped, so the ball will execute an SHM, but how? So let us see. We will find an expression, find the value of k by m. And this question you will get much clear when you do SHM. Okay. So currently I'm just explaining you this question, but if you do your SHM, then you will get this completely clear. So for this, you have a mass here which is falling downward. So first we take this mass at a certain depth. So we take this mass at a depth d, and now its distance from the center is r minus d. R minus d is the distance, and we have studied here. For this we have got something. So what we have got for this? For this we know the value of force. We know the value of acceleration due to gravity. G dash is given as g times of Yes. Do you remember the value? What did we get? We get here 1 minus d by r, right?
Yes, sir.
So g dash we can write as g times of r minus d divided by r. Okay. So here you can clearly see r minus d is the displacement. We can write this r minus d as the displacement y, and hence our expression would become g dash will be equal to g by r of y, right? So if I compare my original expression where I told you that acceleration to be equal to k by m times of y, so here my k by m is similar to g by r. Okay. So I will be putting for g by r, for this g by r, I will be putting omega squared. I will equate here omega squared equals to g by r. Okay. So now I can find out these values. Omega will be equal to under root of g by r. But see, if you go on finding out the square root of 9.8, you will get approximately 10. Find out the value of r, that you will get as r is 6400. So you need to convert it to meter, then obtain, and then you convert it everything. You will be getting your answer here. So can you do this question? How many of you can do this question? Now the question is solved. Okay, the question is solved. The value of g you know is 9.8. So you can use 9.8, or you can use 10 also, because if you find omega, so omega will be equal to under root of g by r. Okay, so you can use like this. So 9.8 and the square root of 9.8, you can find out, you will get 3 point something. Okay, so that would be 3 point something divided by under root of r. R is given here in kilometer, but you will be using r in meter. See, they have given g as 10. You can take g as 10. Okay, so I expect that I'm getting the answer within a minute. Is there anyone solving it out? Putting the value of omega again. Put the value of omega as 2 pi by t. Say 2 pi by t is equal to under root g by r. I want time period. So reciprocate it, and time period will be equal to 2 pi under root r by g. You can put the value of r here. You'll get, you should be, I think I was getting some answer from you. You people will answer. So time period will be equal to under root of r. R is 6400 multiply 10 to the power 3. That's meter, divided by g, which is 10. So if you divide this by 10, you will get here 10 to the power 2. And hence your time period will be square root of 64 is 8. You have here 2 pi. So you have 8. Out of this 20, you will have 80. And out of this, you will have 800. So 800 multiply 2 pi. So 2 pi, your pi is 3.14. Pi is 3.14 multiply with 2. Okay. So this value you get for the time period. Now, this is in second. You need to convert it to hour. So first, you will get 6.28 multiply 800. So multiply 628 by 8. Are you getting the answer?
Yes, sir.
So 628 multiply 8. This you will get 5024. And if you divide this by 60, you will be getting roughly 83 point something. So roughly you will be getting 84. Okay. So 84 minutes. And if you convert this 84 minute, this will be 1 hour 24 minutes. So your correct option is option 2.
Okay, sir.
So be quick in the calculations. This question you will get much better if while doing SHM. Let's do the next one. Yeah. T is the time period of simple pendulum on the Earth's surface. Its time period becomes x times of t when taken to a height r equal to Earth's radius above the Earth's surface. Then the value of x will be. So what will be the value of t? Now we just need to find out the value of g dash at that point. So you have here t is the time period of simple pendulum on the Earth's surface. So you write here t equal 2 pi under root L by G. This is on the surface of. Let us find the expression for G dash. So we have G dash equals to G 1 plus H by R power minus 2. We know the H is equal to R. So we'll put here G equals 1 plus 1. It will become 1 plus 1 power minus 2. So G dash would become G times of 2 to the power minus 2, and 2 to the power minus 2 is 1 by 4. So you have G by 4, here G dash. Okay. So at the place of G dash, if you find out the new time period, so the new time period T dash will be equal to, new time period T dash will be equal to 2 pi under root L by G dash. Okay. So T dash would be equal to 2 pi under root L by G dash is G by 4. So you have here 4. Take out 4 common, you get here 2. So you have 2 times of 2 pi under root L by G, which is your original time period. So what's the value of x here?
2.
2. Okay, so which option?
Option 2.
Option 2. Okay. So I think you can try out such questions.
Yes, sir.
So this, I think you should not require any help over here. Let's see. A body of mass m is taken from Earth's surface to a height h equal to twice the radius of Earth. The increase in potential energy will be, okay. So what will be the increase in potential energy? This, I think we have not studied about the potential energy. Okay. So in the next class, we'll study about the potential energy and try to solve these questions from here on. Let's see if there is any other. This is question number 7 from where we have to start. Okay, you can see this till now. You can see this question. Question 8. Every planet revolves around the sun in an elliptical orbit. Okay, so the force acting on a planet is inversely proportional to the square of distance from the sun. B is force acting on planet is inversely proportional to product of masses of the planet and the sun. The centripetal force acting on the planet is directed away from the sun. The square of the time period of revolution of planet around the sun is directly proportional to cube of semi-major axis of elliptical orbit. Okay, so what options are correct here? If you see the first one, the force acting on a planet is inversely proportional to the square of the distance. Of course, this is correct. Since the force, by the gravitation law, we know that force is F equals to K m1 m2 over r squared. Okay, G m1 m2 over r square. So force is inversely proportional to r square, and it is the gravitational force which is making them move. So option A is correct. Option B, if you look, option B is
Option B is false.
yeah, option B is false. It is directly proportional, not inversely. The centripetal force acting on the planet is directed away. It's false. Centripetal force is always directed towards the center. It is directed towards the sun. Then the square
Option
of
D is
time
true.
period of revolution. Option D is true. So A and D only. That is option A. Okay. Okay. So bye everyone. We'll see you again in the next class.
Okay, sir.
Okay. Bye.
Thank you, sir.